Hello everyone. Today I want to show you a prototype of a secrets management solution that is a first-class citizen to SPIFFE. SPIFFE, as you may know, is Secure Production Identity Framework for Everyone. It is a way to distribute identities and certificates at scale. And this solution that I call is SPIKE, Secure Production Identity for Key Encryption. It's a secret store that stays on top of SPIFFE, and it accepts SPIFFE as its identity plane essentially, and it doesn't need anything else. It doesn't need Kubernetes or any kind of manager or orchestrator to run. As long as there is SPIFFE, it can work as a secret store. So it nicely dovetails into SPIFFE, or it nicely complements SPIFFE as a secrets management solution. So that's one benefit of it. And the other benefit is because it's using SPIFFE, it's platform agnostic, so it can run anywhere essentially, anywhere that you can run SPIFFE. So there's a architecture document. I'll just briefly go through it. I'm going to share this document to the greater audience, the greater open source community when it is finalized. It's mostly, in a good shape, but I just want to demo how the tool works rather than going through the all of the discussion about architecture and sequence diagrams and whatnot. Because first of all, this is still in design phase, so these sequence diagrams might change. And secondly, while making this initial demo, I had to take shortcuts and assume that certain things are working, and I had good enough evidence that things were working, but I didn't fully implement the workflow. So what the solution that I show might deviate from what these sequence diagrams entail. So that's why it's better to show something working than explain everything, I guess. And I can also explain things while I am showing the demo. But it's a pretty much detailed discussion about data models and what's using the security, threat analysis, and a overall discussion of the solution. There is a markdown file about it, and this is an open source project. Where it will stay is still in discussion. So that's why I am not sharing the repository. When there is a place that we know for sure where it will stay, then I'm going to share the repository as well. But it's an open source project that we are going to publish with a Mozilla public license. It will be pretty permissive open source license essentially. So that said, let me go through the source code. This is my Spike workspace. So I have my source code, my binaries and whatnot. One folder that is of particular attention is this hack folder, which I have certain utility scripts to make my life easier essentially. So one of those is the build spire script. Let me cat that one. Hack build spire. It's this is like a Ubuntu Linux machine. So what I do is to I need a Spire, or something SPIFFE compatible to run on my system so that I can run Spike on top of it. So I just clone SPIFFE source code, and I do a bunch of configuration, and eventually I have Spire agent and Spire server binaries that I can run on my system. Other than that, let's see what else I have. I have this generate agent, not that one, sorry. I have the Spire agent starter and Spire server starter shell scripts. So those are I need a Spire agent and Spire server to run on the system. But for that, there are several ways to initialize a Spire server, Spire agent tuple and let them establish trust between each other. In this one, I'm using a join token. So this Spire agent starter or Spire server starter will create that token, and we give that token to the Spire agent off cycle. But how that relationship is established doesn't matter. Like when you are using Spike, you likely have an already running Spire installation or a SPIFFE compatible system there. So you will, as long as you configure Spike to talk to that system, how that system is configured will not matter that much. But let me show you those scripts one by one. Spire server starter. So it runs, like, it builds the binaries first. Let me show you by, where's my arrow? It builds the binaries, and then uh, I locally save a bunch of tokens to make my life easier. So it clears those tokens so that I can start with a clean slate. And then it starts the Spire server. So that's the order of events that it does. Build spike. Let me show you. It's it's just go build, but for the sake of completeness, cat hack build spike. It's just running a bunch of go build commands. We are running this with Go experiment boring crypto to make FIPS a compliant. What is FIPS? Yeah, it's FIPS to make FIPS compliant binaries, and we also use FIPS compliant algorithms to make this project like runnable on certain highly governed entities. Essentially, that's one thing that the build system does. Other than that, let me see what was the other things that it was doing. Clear data is clears a bunch of tokens. I'll just skip that one and start Spire server cat hack start Spire server. It just runs the Spire server with certain configuration files that has been defined. So we have hack Spire agent starter. Similarly, what it does is it creates a agent token down here. It registers a bunch of Spire entries. I'll show them because it's important for all of the other components to communicate with each other. And then it starts the Spire agent. So let me show them one by one. Cat hack generate agent token. So it's like we talk with a Spire server to create a token, which we will use this token with the Spire agent to let Spire server and Spire agent to like identify each other. That is one of the ways that Spire server and Spire agent can establish trust. There are other ways too. Like for the interested, I encourage you to go to SPIFFE documentation at spiffy.io and like see how other mechanisms of trust establishment between Spire agent and Spire server are. So what else does it have? Register Spire entries. Let me show that one. Cat hack register Spire entries. So here we are doing a bunch of stuff. I'll just go to the gist of it. So we are creating registration entries on the Spire server for a bunch of entities, which are Spike Pilot, Spike Nexus, and Spike Keeper. So Spike Pilot is the binary that we enter secrets or get secrets. You can, for the sake of the discussion, you can think of it as the Vault binary if you are using HashiCorp Vault or if you are familiar with tools like HashiVault, essentially. Spike Nexus is the secret store. So Pilot registers secrets to Nexus, and Spike Keeper is a tool or is a component that Nexus talks to back up or to back up certain crypto material. So Spike Keeper is for redundancy essentially. So what happens is Spike Nexus, when it bootstraps, creates a initial root key if it doesn't already have one, and then it backs up that root key to Spike Keeper. And whenever, like for example, if Spike Nexus crashes and it loses its root key, then the first thing it will do is to ask Nexus, like, "Hey, Nexus, sorry, it's Spike Keeper saying, hey Keeper, do you have my root key by any chance? If you have it, can you give it to me?" But how do these two trust each other? By these registration entries. With those spy server registration entries, these Keeper and Nexus can establish MTLS with each other, and that's why they can securely communicate and fetch things. Because without those identities, there won't be any communication. And since, as the administrator, we are giving those entities these identities, we can be sure that these are trusted. These can trust each other. And how do we validate those identities? There are certain things. Since this is a Unix environment, we are matching its user ID. We are matching the path that the binary runs, and also we are matching the SHA hash. So if, like, assume a hacker comes and puts their own binary that has some malicious code, then this SHA hash, let me show that one here. This SHA hash here will be different. It will not match the entry that we created, and they won't be able to use their counterfeit binary essentially. Uh, these selectors that we define here kind of keeps those identities secure and cryptographically and uniquely identifiable. So if we have compiled this spike keeper binary, we can be sure that that's the binary that we are seeking for. So at least we can be sure about the identity of the source code. We can be sure that it is trusted because we know the SHA hash of it. So that's a way to establish trust and give identities to workloads. This is how typically SPIFFE does workload identification. It does off-cycle workload attestation rather than providing like usernames, passwords, or like service tokens to applications essentially, which, if you ask me, is a better way to attest workloads. That's that one. And we have Spike Pilot. Yeah, we talked about Spike Pilot. Spike Pilot is the CLI, which is the Spike binary itself. So Spike Pilot stores, let me revert this one, stores secrets to Spike Nexus. But to be able to like use the pilot as the first administrator, which you'll be a super admin in that case, you have to initialize it. By initializing, I mean there is a token, unique token created for you so that you can identify yourself, and like when you do something, it is auditable because you are identified by that super admin token. So if you do something funky, then there will be traces of that funkiness or whatever. So that's that one. This is how we create identities for the components of the application, and the components are a Nexus, Keeper, and Pilot. Pilot is the front face, and it is typically what an administrator or what an operator will be using, and the other two components will be running in the background, syncing up with each other and like having fun. So that's that. What else? Agent starter. Yeah, and start Spire agent, clear cat hack start Spire agent. It's just using the join token that we created before, and it's creating the agent to establish a trust relationship between the server and the agent. So first, I'll start the server because agent needs to talk to the server. So it logically makes sense to first start the server first. The order in itself doesn't matter. They figure out and like balance each other, but starting the server is a cleaner approach. So I'll do what was that one? Starter Spire server starter Spire server starter.sh, and I have my server healthy and running. I'll do hack spire agent starter.sh. So I have my server here, my agent here. So I need two other things. Like I said, one of them is the keeper and the other is Nexus. I'll start them as well. Clear. If I list, you'll see that we already have the binaries for keeper, Nexus, and Spike, which is a pilot down here. So what I'm going to do is I'll first start Nexus, which is a secret store. I'll then start keeper. And this will wait for a while, and then the Nexus and keeper will start interacting with each other. They already started. They start talking to each other periodically, and it will say, like, the Nexus will say, "Hey keeper, I have a root token. Can you safe keep it for me?" And the keeper will say, "Oh sure, Nexus, I can," and it will store it in the memory. Those secret keys are never stored on file, at least on plain text on file. So if a secret or if a key is going to be stored on the file system or in the database, it will be first encrypted, then stored. And the topmost encryption key is the root key. It is backed up by a keeper. So one thing that might happen is, like, if let's say this this Nexus crashes and then keeper crashes and then somebody brings them back up, then the root key is already essentially gone, because there is not in memory copy of the root key. To make this possibility happen less, we can add more redundancies. We can have more keeper instances. That's one way to sort out that problem. And the other is, you can get an encrypted backup of the root key and secure it somewhere safe. So when, in an unlikely case that both Nexus and Keeper crashes, then an operator can manually initialize the system by either entering a password or like entering a Shamir secret, for example, or like some other manual mechanism. But the system is designed in a way that not this one, sorry, in a way that this keeper will be enough to keep the system healthy, so that, you know, if something happens, the spike nexus can talk to keeper and rekey itself or reinitialize itself. And the reason we do this is to, like, it's a user perspective essentially. Or maybe user experience or user centric design. We want the operators, DevOps, and like site reliability engineers to sleep more, and that's why we would like them to manually intervene less unless they have to. So that kind of, you know, adds a level of automation to keep the system up and running without having manual human intervention to change things essentially. That's one thing. Let me think about, do I have anything else to share here? I don't think so. Let me show, you know, how the CLI works. Our binary, which is Spike Pilot, is called Spike for convenience, because I don't know, I like Spike more than Pilot. So when you call Spike, it will say, hey, this is the version. There's a website that you can go and, you know, see more details about it. And there's a documentation or like a brief summary about what kind of commands that this Spike instance has. Right now, it is not initialized. So if I try to do like Spike, come on, Spike put, what kind of entity do I put? Let's say tenants Pepsi, DB credentials, and like user admin, password Spike Rux. If I do this, it will say, hey, friend, the system is not initialized yet. Can you please init and then try? And so, and it also says, you know, please run Spike init to initialize the system. So I'll do that. Let me clear this one. Spike init. It initializes and saves a token for me to use. This token is this is the initial design. That's why we are using this token. But later down the line, the admin user will not need the token. The admin token will be created and stored in memory of Spike Nexus somewhere around here, and the admin user will use a strong password to retrieve that token, essentially, and not that token for to be clear, by using a strong password, and like while they will do something like Spike login, and when they log in with a password, they'll have a temporary, short-lived token that they can use for that particular session. It will be more secure, but for the sake of this demo, we are using this generated and stored token to validate the authenticity of the admin user. But the rest of the things is like SPIFFE MTLS. So any communication between like Spike and Nexus will be TLS protected. So this is MTLS. It is both of the parties know each other, so the communication will not happen unless these two folks trust each other. And you cannot do a monster in the middle attack because this is MTLS. And later down the line, there are works to establish post-quantum security to SPIFFE provided algorithms as well. There is a issue and there is a pull request that the Spire team is working on. So later down the line, this will be maybe the first post-quantum secure and post-quantum safe secret store that's on the planet, which is cool to say, I guess. So that's that one. Let's see what else. So I need to initialize. Actually, I initialized Spike, so I can just rerun the put command again. Spike, and if you see the design, how you use these commands and paths is looks a lot like a HashiCorp vault, and it is intentional because, like, if you are using a secret store or if you are seeking for a secret store, probably you have heard and you have probably been trying and experimenting with Hashi Vault. And most of the people around you, your friends, your colleague, your team, your customers, know the Hashi Vault interface better. So instead of reinventing a new way to provide secrets, we follow the same approach so that the user of a new secrets management solution won't at least be unfamiliar with how the secrets are created or implemented or entered, and like how they can do like policy management on secrets and things like that. So because if you have a known model, then you can define like, hey, I want Pepsi's secrets not be shared with Coca-Cola or whatever, or Starbucks. Those are just names that I'm making up. Nothing, but so the gist of the issue is like you can use the known business rules or known ways of dealing with secrets while having a really lightweight, secure, and fast secrets management solution that runs on SPIFFE. So it will be like you'll be familiar, you'll be like at home while using the solution, but it will be something different without looking like something different, if it makes any sense. So that's how we create a secret on a path. You can also version the secrets and like delete versions. It's more or less, like I said, this is more or less Hashi Vault compatible, but not entirely. There are some differences, of course. So let me save this one, and it says, okay, I saved your secret. So let me get it. Spike get tenants Pepsi DB creds, and yes, my password is Spike Rux Spike, and my user is admin. So that's all I have to share for now. This is like a work in progress. I am right now. I am not saying contributions are welcome because we don't even know where to put this project yet. It will likely but I'm not promising anything because it's still under discussion. It will likely go under SPIFFE umbrella, or maybe it can become a incubator project on CNCF, Cloud Native Compute Foundation. Uh, but it's right now where it is going to head towards. It's not stable yet. I'll let you folks know when it is when there's a home for this project, and then anybody can contribute to it. So I'll be the lead architect of the project, but I'm sharing everything, all the design documents, all of the architecture diagrams, architecture decision records, and the full documentation, source code, and it's open. Anybody can add value to it as long as you are willing to play with secrets. You have fun doing spiffy stuff. You have a keen interest in certificates and managing certificates. It's a niche topic, but it's fun. And it's an open community, so we'll help you along the way. Don't shy away. But that's for now all I have to share about this secrets management solution, Spike, secure production identity for key encryption. And until next time, keep your secrets secret.